Welcome to Let's Talk Security, where we spotlight cybersecurity companies and give an inside look at the people and technology behind the latest advancements in the industry. We discuss a wide range of topics with subject matter experts about today's cybersecurity challenges and how their solutions are helping organizations like yours maintain a continuous security posture. Please welcome the host of Let's Talk Security, Jeff Wolach.
Today on Let's Talk Security, I will be speaking with the company ProfiTAP. I'm here with Mike Pennacchi, Network Protocol Specialist. Thank you for joining me today.
Thanks, Jeff. Good to be here.
Mike, I have a few questions I put together for our chat, so why don't we just jump right in?
All right.
Tell us a little bit about ProfiTAP and your role as the Network Protocol Specialist.
So ProfiTAP is a company based in the Netherlands, and for a lot of folks here in the U.S., probably not. They may not have heard of ProfiTAP until the last few years. They've been around for 35 years, building tools for getting in the path of the packets and being able to go in and monitor network traffic. And so one of the things that's unique with ProfiTAP is the ratio of engineers versus other folks in the company. They're a very engineering heavy company, and they focus much of their efforts on designing unique products. There's a number of products like the taps that you're going to see in a number of different places, but they take a lot of time to go in and design products that go well beyond what we see with some of the other products out there on the market when it comes to not only tapping, but recovering from power loss and things like that. So it's a unique company to work with that I've found in that they really focus on what new things could we come up with to make network analyst lives a lot easier.
And your role as the Network Protocol Specialist?
So I spend a significant amount of my time going in, developing training content. You might see some of the videos I've put together out there, helping customers understand how to best use the products, and providing feedback as far as what features would be useful. And so that's one of the things that we see is that I spend a good portion of my time going out and troubleshooting network problems and helping others do the same thing. So I get a chance to find out, what is it that we need in a product, and then I can work with the engineering staff there to help them implement that. Very
cool. You've been in the industry a while now and are considered one of the most sought after authorities on network packet analysis. In doing my research, Mike, I noticed that you were part of a team that was contracted to optimize the Pentagon's networks after the events of 9/11. Without compromising national security, would you share with us that experience?
You bet. For quite a few years, actually, toward the beginning of my career, I traveled around doing training classes on network troubleshooting, and some of the folks that were in charge of the network there at the Pentagon were in the classes. And after the plane struck the Pentagon, it had taken out one of the data centers there, and traffic had to be rerouted through other parts, and it wasn't running at nearly the speed they expected. So after working on some of it themselves, they called myself and another team of other folks out, and we went in, analyzed the problem, found the bottlenecks, resolved those bottlenecks, and then validated that we were able to increase the speed, in that case, 50 times over what it had been.
Well, I'm sure that was a very interesting experience that you probably didn't want to do.
Exactly.
Or have to do.
Yeah.
But you did. So thank you very much for that. Now I'm going to go in the Wayback Machine in 1995. When you went to your first Interop show and you were trying to figure out how to solve a network problem. And then 2 years later, you became an instructor at Interop and have been teaching at Interop since then, and probably the past 24 years now. So what an awesome accomplishment.
It really has been.
Tell us a little bit about how you became an instructor at Interop and the experience with helping others.
Well, you mentioned 95. In 1995, I was network administrator for a company here in the Seattle area. And I don't know how many folks on this that are listening are going to recognize the system Banyan Vines, but we were running a Banyan Vines network operating system. And every morning at 9 a.m., almost exactly every day, we'd see our core router reboot. And so I headed off to Atlanta to Interop 95 to figure out how to solve that. And I went and listened to a group of people talk about packet capture and analysis. I figured out what I needed to do when I got back. We captured some packets. We thought we had the right packet. And we thought, well, if we transmit this packet and it really is the right one, it'll take the network down. So we did. And I don't do that type of thing anymore. At the time, it was not the core part of the network. And so I got hooked. I was able to go in and capture packets, solve a problem, identify what was causing the problem, and rectify that. A couple years later, I ran into the owner of that company, and he said, why don't you come work for me? So I went to work for him, and they were presenting at Interop, so I had a chance to start teaching there. And that was kind of the beginning of that 24-year run. And over that time, I've been an instructor, I've been the lead network engineer, I've been a sponsor. So I've gotten to hold a lot of different positions there and meet some phenomenal people that have worked on that show for a great number of years.
Well, I'm not sure if you know this, but if you go to interop.com, your picture is right on the front page. So kudos to you.
Oh, thank you. This was a little different year. We just, last month, actually the beginning of this month, we had the show, and it was different than years past, but we had some, people attend, and it was fun.
Well, knowing what to look for in packet capture is important. However, where to look is probably more important. I saw you wrote a blog about getting in the path of packets. Would you care to elaborate on that blog?
You bet. So one of the things that we find is that, I see all the time people want to learn how to use different analysis tools and get better at it. And one of the things that happens is they don't look closely enough at getting in the path of the packets. If we don't capture the correct packets, whether we're doing security analysis, packet capture analysis, performance analysis, we're not going to be able to solve the problem. So we need to make sure that we do everything possible to get ourselves the best information to start with and the right information. And so that's something that I harp on all the time is how do we get in the path of the packet? So we have to know what that path is. We have to select a method that's appropriate for getting in the path of those packets. And then we need to validate that we are getting the right packets before the problem occurs, because once a problem occurs, it doesn't give us a second chance at coming back again in most cases. So we need to get it right the first time.
Yeah, I'm very familiar with that. Going back in my day, I used to work for Network General, the company that made the sniffer analyzer. And so I'm actually familiar with those Interop shows in Atlanta. I worked many of those shows myself with Network General. But yeah, you're right. Getting into path of packets is very important, because if you trying to find something that was intermittent, it's very tough, because guess what? It doesn't happen when it's supposed to happen.
Exactly.
And that leads me to more long-term type of packet capture. That's really paramount these days, especially when you're trying to look for those intermittent problems.
Yep.
So how can we take that same approach when we're looking for network problems to look for security problems with long-term packet capturing?
Well, and that's one of those cases where oftentimes with security issues, we may see that something happened. There may be an incident that is significant enough it gets our attention. So the question always comes up, how long has this been going on? That happened to be the event that occurred that set off the alarm, that triggered our system, that let us know something was going on. But rarely does somebody get that attack right the very first time. Maybe they've tried some other vectors to get in there and try and get in and attack the system. So being able to capture and store that data over a period of time gives us an ability to roll back in time and take a look and see what's happened. Now that we know the IP address, now that we know the port numbers, now that we know signatures of that attack, we could go back and take a look and see what else has this device been doing? What else have they tried to get into our network. And in some cases, maybe they were able to get in. We just didn't know to look for that particular thing. So have that back in time analysis, as well as, you brought up intermittent problems. I have yet in my career to have somebody call me up and say, hey, I'm going to have a problem in about 3 hours. Could you get the analyzer set up and start monitoring? And pretty much every case, they say, what happened last week on Tuesday? Things seem slow. And if we weren't monitoring on Tuesday and still had that data available to us, we're not going to be able to see what happened. And we're going to have to shrug and say, I don't know. And we want to build credibility with our clients, and we want to make sure that they feel like if something does happen, that they're able to go back in time and see what's going on.
I know a lot of organizations contact you when they can't figure something out. And I'm sure you have some pretty interesting stories, especially during the pandemic. Would you care to share some of those stories with us on how you used packet capture technology to help, organizations during the pandemic doing some transitioning to work from home?
Sure. There's a couple issues that we've run into. One of them is VPNs. When this first started, a lot of folks that maybe weren't working from home before needed to be able to connect into their work networks. And so what we found was that early on, a fair amount of troubleshooting effort went into helping people determine, why is this VPN not working? The other thing that we run into is the distributed nature of workers right now. And in the past, maybe somebody had a significant problem, hop on an airplane, fly out there, help them troubleshoot that. And that's just not an option right now. So what I found is that we've depended more on being able to take tools that have good remote access capabilities, ship those tools out to them, and then walk them through, this is how you put it in line. And so once we can get in the path of those packets, if we have a tool that allows us to capture and analyze the traffic on that tool, then we're minimizing the amount of traffic that we have to send across a wide area network when we're going in and doing that analysis. So we're able to pull the packets back that exactly relate to that problem that we're trying to solve. So once we got the VPN issues resolved, now we found that we're moving more out to that far end to help find out what's going on. A good example of that is I was working with one of my customers, and they said, when I'm in the office, I have no problem mapping to these shared drives. But when I'm out of the office, I can't. And so we sent an analyzer out there, we did the capture, and what we found out is that the issue was name resolution. That when they were in the office, the DNS server there would append a domain name to all of their searches. So they could just put in the first part of that share name, where when they were home, they had to put in the fully qualified domain name because the DNS server there wasn't handing out the same information. We could have spent a lot of time trying to troubleshoot that, where being able to have a packet capture tool out there, capture that traffic and be able to see what was going on, significantly reduced the time it took. It was, once we got the capture, it was a matter of minutes before we were able to determine exactly why they weren't able to map to those drives.
Yeah, it's funny because people don't realize the importance of DNS, and when they're trying to type in a name, it needs the full search domain. So it's kind of interesting. And You see some of those things, you're right, just kind of misconfigurations because they're trying to get things rolled out very quickly. So you probably used probably every packet capture and network tap technology out there, I'm sure, throughout the years. Tell us a little bit about the ProfiTAP line and what is it that you really like about it?
So there's a number of things. And one is that when it comes to things like fiber taps, fiber taps are passive devices. So light goes in, light gets split, light comes out. But what we've seen with ProfiTAP is things like coming up with a third U fiber tap. So sometimes in a rack, we may not have a lot of extra space to put something like a tap. So engineering something that takes up only 1/3 of a U, now we can slide that tap in there and get in line, but not use up a lot of extra space. Another one, time to recover after we lose power. One of the things that we started to notice with copper taps is, many companies have fault-tolerant copper taps. And these taps are designed that if the tap loses power, that it will close and continue to pass packets. But when you look at how long that process took, in a network, it was incredibly long. So I had done a little test to go out and find out, how long does it take to recover from this? And we compared the ProfiTAP copper tap with some of the other ones out there on the market. And we found that when we lost power, they were comparable. It was when they got power back that we saw the big difference. And with the ProfiTAP tap, it was able to recover in about a quarter of a second, where we saw with other taps, we were looking at up to 4.7 seconds. So that's a long time to lose packets. So that ability to go in there and take a look at some of these finer points that differentiates their taps and their monitoring solutions from some of the other ones out there on the market.
I know you did a video that's out there on the differences between the various taps and their time to recover. And it's pretty interesting. I would encourage everybody to go ahead and take a look at that video and learn more about how the ProfiTAP tap really does recover a lot faster. How about their network traffic analysis solutions? They have a couple. You want to talk a little bit about those?
Sure. So they've had a product called the ProfiShark out for a while. And the ProfiShark is a small little box that we can put in line, both on 10, 100, 1000, and they have a 10 gig version of that. And it will take and tap in line, so it passes the packets, and it will fail over to wire. So if we do lose power to it, it will continue to pass packets. And on the 10, 100, 1000, it passes PoE. And what it does is it takes those packets and sends them out a USB 3 connection. So this allows me to take a PC that supports USB 3 and get in the path of the packets and start monitoring that traffic and see what's going on, and be able to do that at a rate where we can get all the packets. Now, 10 gig, not going to get all the packets. USB 3 is just not going to support that. But when it comes to up to gig, be able to do full line rate, full duplex traffic capture. So they had written some drivers to work with the Synology NAS. So then I could take that ProfiTAP device and plug it into a network attached storage device and write those packets to disk and set up something like a SMB file share. So now I could have that in my network, and if a problem occurred, I could map to that drive, go out, grab those files, and see what was happening at that time. So we were having an online call, and I said, what'd be really cool, and I grabbed a little Pelican case, the NAS, and the ProfiShark, stuffed them all in that box, and I said, if we had something that combined these two, that made it really easy for somebody to do that analysis. So Laurent, the CIO or CTO of ProfiTAP, went out, started working on that. And with his engineering team, and about a year later, they came back with the Iota. And the Iota takes that tap and the capture to disk technology and combines it into one very small little box. And they went a step further and they added ProfiSite on top of that. So what happens with the Iota is that the packets are captured and written to a file. That file is then analyzed, and the metadata from that file is put into an Elasticsearch database. So now I can go in and very quickly search on things like IP address, port numbers, applications. I can look at a variety of different factors that go into an application flow. So this gives me a way that I can create a filter, graph out the traffic, and very quickly see what's going on. And then if I want the packets to back that up, I just say, hey, I want to download that PCAP. It'll grab that traffic that matches that filter criteria, pull that down to my machine. Because all of that's being done on the Iota itself, it means that I'm not having to copy gigabytes worth of traffic across the network to analyze it. But instead, I can focus that analysis. So This gives me a number of things that I'm always looking for successful packet analysis, and that is being able to get in the path of the packets, do that in a way with the copper 10100, 1000, where I am not putting something in line that if it fails or loses power, that it's going to take the network down. It's capturing that traffic, writing it to a 1 terabyte drive, and then giving me the ability to do analysis on that and bring those packets down. So in a tiny little box.
I've seen them before. They're great. They also have one for 10 gig, correct?
That's exactly. So they have one that has a couple of SFP plus cages on it. So it supports both 10 gig and 1 gig on that. And so again, if I need to get in and monitor 10 gig traffic, I can grab that traffic and see what's going across the wire there and analyze those packets.
I know you and I were speaking before our interview, and we were talking a little bit about the IOTA. And one of the things you had mentioned you liked about it was actually, being able to ship it out to a customer site and just having somebody plug it in and then hit that start button. Tell us a little bit about how that works.
Well, and that was one of the things that in our discussion came out is, I always like to throw these pie in the sky, this is what I'd really like to have. And one of the things that we discussed was, you ship this out to somebody, we want to make it easy for them to start that capture. So what you find on the IOTA is that you've got a management port, which will run the IOTA off of PoE. You have the inline tap, and then you have a push button. And so really and it comes in a little Pelican case. So you can put that, well, I shouldn't say Pelican, it comes in a waterproof case. And you can put it in there, stick a label on it, ship it out to the person that needs to do the capture. Really, if you throw it comes with an extra patch cord. You take that patch cord, you put this in line, they plug it into power. As soon as the lights stop blinking, you say, just hit the start button. They hit the start button, the capture light will start flashing, and now they're capturing. So we wait. It could be that day, it could be a week. It's writing that data to disk. As soon as the problem occurs or we've captured the traffic we want, they can push that button again to stop the capture, disconnect the power, put it back in the box, ship it back. So now we have this device that we can start analyzing that traffic, find the time when the problem occurred, see everything that was going across the wire between that device or that group of devices and the rest of the network, do the analysis. And we can do that without having to fly out there. And one of the things that we found with having to fly somewhere is you burn up a day traveling, getting there. I'm on the West Coast, so if I'm flying to the East Coast, I got to adjust to the time zone. It'll be 1 a.m. in the morning. I'm still wide awake, laying there in bed, thinking I need to get to sleep so I can get up in the morning. You go out and do the analysis, then you've got to get back. Where with this, because I can put that IOTA in the case and ship it out, I can have more than one IOTA. So I can have multiple projects going on at the same time. And on top of that, they built support for zero tier into the IOTA. And zero tier is a VPN cloud technology where we can go in and we can put in a zero tier network ID in there. And this device will establish a VPN connection back to zero tier. And we can then access that IOTA through that VPN. So if I ship that out, if I want to start doing some analysis on that traffic, even before they send it back, even if that's behind a firewall, a NAT, I have that ability to get in there and access it. And I use that not only for troubleshooting, but for training purposes. I've got a couple of clients where as we work through the IOTA, they put in my network ID. I can then log into that IOTA, and because it's a web-based interface, they're looking at the IOTA, I'm looking at the IOTA, and we're both able to go in and work through that. So it gives us a way to do that training, or they can connect into one of mine here and access that. So especially in the environment we're in, where remote analysis becomes very important, it provides us that ability to get the information we need without having to hop on a plane to go do it.
Yeah, that is great. That is a great feature, definitely, of the Iota. I know they also have, ProfiTAP also has some packet brokers, aggregation taps. You want to talk a little bit about those?
Absolutely. And that's, the thing with packet brokers is that as we start putting taps into our network, we've got all these sources of traffic. And then we have our analysis equipment. And I might have an IDS system. I might have something monitoring my voice over IP system. I could have a variety of different analysis tools. And all of those tools don't need all the data. And rarely can we put a tap in one place that gets us everything we need. So this is where the packet broker really comes in. And the packet broker allows us to put a device in the middle that's going to aggregate all of these sources of packets together. We can grab span ports, we can grab taps, and we can pull all that together. We find that in many cases, if we have redundant links, we have redundant routers, redundant links go into those routers, that some of the traffic may be going outbound on one link and coming back inbound on another. So we need a way to pull all that together so that we're seeing one flow. This is really where the packet broker comes in. And in addition to being able to perform that aggregation, it allows us to apply rules. So I can say, I want to take this type of traffic and send it out to this particular tool. And this works well for both ensuring we're not overloading that tool. We see, people say, well, can we capture full line rate 10 gig? Well, maybe the tool that they're using can't capture full line rate 10 gig, but the traffic they really need isn't full line rate 10 gig. And so in the end, they just have to filter out a whole bunch of traffic, and it's going to burn up their disk faster if they're doing capture to disk. So why not reduce the amount of traffic going to that tool to just the traffic it needs? That optimizes that tool. It doesn't have to capture at as high a rate, and it allows that capture to disk to last longer. There's also security reasons for it. I may not want everyone to see the voice over IP traffic. So by being able to filter that traffic out and send the traffic that they really need, I'm not sending traffic to an analysis tool that they shouldn't be looking at. So the packet broker allows, in summary, it allows us to take all of these different traffic sources, apply filters, apply rules to that, and then distribute that traffic out to where it needs to go.
That is, definitely something that, organizations that have a lot of tools that don't have the ability to create various, separate span ports to gather that information. Packet brokers excellent for that, and pulling that all together with the Iota, the ProfiShark, and their tap technology really is a very powerful set of tools that the organization has. Your marketing department sent over a video of you analyzing some packets and uncovering some security issues. Would you care to set up the video clip for us?
Sure. In this video, what I'm doing is I'm going through and showing how we can identify somebody trying to get into the network. And then once we have that information, be able to go back several weeks and see what else they've been doing. How long has this been going on? And what we'll see is not only can we see the IP address, we can see the traffic, but we're able to go in and use the geo-IP location information for that device to find out where that device is coming from. So this gives us a way to, in this video, we're going to show how we can go in and see how long has this been going on and who's been doing that.
All right, let's take a look at that video.
Hello, Mike Pennacchi here. In this video, we're going to take a look at how we can use a custom dashboard on the Iota to go out and investigate those devices that are trying to access our network from the internet. So let's go in, and we're going to start by taking a look at the Iota home dashboard. So in this case, in looking at the Iota home dashboard, we can see all the conversations that have been going on. We can see how much traffic we've seen. And in this case, we're taking a look at the last 3 hours. And this is a lot of really good information about what's happening with our network. In fact, in this case, we're using the Iota combined with the booster to capture in a number of different places. But what I'm really interested in this case is who is trying to get to closed ports on the outside of my firewall. Now, one of the connections on the booster is between the firewall's outside connection and my cable modem. So what I did was I put together a custom dashboard. And this is one of the really neat features with the Iota, is not only is it capturing all the packets and writing it to disk, but it gives us a means to go in and create custom dashboards to allow us to view the traffic in a way that's meaningful to us. So what I'm going to do is I'm going to come up here to the top and I'm going to go in and I am going to find my blocked ports analysis. So again, this is a dashboard I put together. And what this dashboard is doing is it's taking this filter I put in here, and that filter is going in and filtering out all the HTTP and HTTPS traffic that's coming into my network because I expect to see that traffic. And now, up at the top, it's showing me the number of inbound TCP SYN packets for all the ports other than 443 and port 80. In addition to that, it's taking the GeoIP location of each one of those devices and it's mapping it out so I can see where those hosts are. And down here, I can start taking a look at what IP addresses are trying to get into my network, what ports are most used, and what devices are accessing that. Now, what I'm going to do is I'm going to back up. I'm going to take a look at a larger span of time. So in this case, I'm going to say, you know what? I'm interested in the last 7 days. And this is one of the huge advantages to the Iota, is it's taking the traffic that has been captured, it's analyzing that traffic, and it's writing it to an Elasticsearch database. And it's that database that I'm using to create these dashboards. So now I can start getting an idea of who's been trying to get into my network, and I can see over what period of time they've gone in to try and do that. So in this case, I'm going to come down and I'm looking at my various IP addresses here of devices. And what I might do is come down and find a device like this one right here that has tried to get in on multiple ports. Now you'll notice that when I fly over that device, it shows a little magnifying glass right there. This allows me to very quickly go in and create a filter on that particular value. Now that value could be a country code. It could be a TCP port number. It could be an IP address. So in this case, I'm going to set a filter on that IP address right there. Now, when we go up to the top of the screen, what we notice is it's now set up a filter on that IP source address. So now I'm drilled in and looking at specifically this device. And I can start seeing over the last 7 days, how often has it tried to get in? Now, in this case, I'm really interested in a longer period than that. What has this device been doing over a longer period of time? So I can come up and expand my search. And this is the great thing about capturing over a long period of time. I may see something that occurs right now, but I want to go back in time and see how long has this been going on. Is this something that just started? Or is this somebody that's been trying to get into my network for an extended period of time? So in this case, I can see that over the last 30 days, periodically, this device has been trying various ports on my network. And we can come down here and we can start seeing which ports that device is trying to get into. Now, this is just looking at TCP SYN packets. That's all I'm interested in for who's trying to get into my network. If I wanted to go in and see, had they been able to establish any connections, what I can do is come over here to my list of dashboards, and I could go to something like my TCP troubleshooting dashboard. Now from here, this is going to show me things like TCP SYNs, TCP ACKs, FINs, resets. So if that device was able to connect into my network, I would see some TCP SYN acknowledgments. I'd see some ACKs, some FINs. But in this case, it's good. I haven't seen any ACKs, resets, FINs. So they've been knocking on the door, but they haven't been able to get in. Now, if I wanted to go in and analyze this traffic with something like Wireshark, I could now come in and click on Download PCAP. And, well, this is going to take a while to run, because what's going to happen is the IOTA is now going to go back through 30 days worth of capture file. Now, this IOTA that I'm using has a 1 terabyte hard drive in it. So how far back in time we can go is limited based on the size of the drive and how much traffic we see going across our network. But the great thing is I can now go back and take all those packets that were captured for that device, write those out to a PCAP file, and open a tool like Wireshark and start analyzing it. So the great advantage we have here with using a tool like the IOTA in line with our network connection is being able to capture over an extended period of time, do some high-level analysis of those flows of traffic using the database that's in here and using the ProfiSite application. Once we find a device or a port number that we're interested in, I could then come in and download that capture file and conduct further analysis on it. If I wasn't capturing the traffic, I wouldn't be able to roll back in time and see what's going on. So this is one of the many advantages that we have when we use the IOTA to capture and analyze our network traffic.
Mike, that was a great video. Thanks for sharing that with us. It really showed a lot of good information that hopefully the audience can benefit from. I know there's one other product from ProfiTAP that we were remiss to talk a little bit about, but I'd like you to share some information about it, which is their booster technology. Could you talk about that?
I will. I'll tell you, I'm really excited about the IOTA. The booster is one of those tools that when I saw this, I thought, man, here's something that's been missing from my life. I think the booster is one of the coolest things in here. In fact, let me just flip over here. And so here I've got an IOTA, and this is one of the 10 gig IOTAs, and it's connected via a DAC cable. So instead of using fiber, we're using coax there to connect the IOTA at 10 gig to the booster. And what we see with the booster is the booster has 4 10-100 1000 inline taps. So I've got this set up, and it is tapping both inside and outside my network. And these 4 taps support full line rate, full duplex gig. If you think about it, if I take and I'm running at full line rate on all 4 of those, that only adds up to 8 gig of traffic. So I'm not going to oversubscribe that 10 gig output port. The other really neat thing with this is that it allows me to go in and measure the latency of devices. By putting it on the inside and the outside of my firewall, I can see a packet come into that firewall on one port. Then I can see the packet come out of the firewall on a different port. So what this does is when I look at my trace, I can now look at the delta time between those 2 packets, and I can see exactly how long that device held it. And I got to tell you, I was a number of years ago around Christmas time here in Seattle, my wife and I were just dating at the time, and we're standing in line, and the person behind me, we were waiting to see these gingerbread houses that architects had built. And the person in line behind us was telling the person they were with that they didn't get the email because the firewall held it for 3 or 4 hours. And my wife, who again, I was just dating at the time, knew enough about me that she looks at me and she goes, don't just shut up. Don't say anything. I said, but it's killing me. There's no way the firewall could hold it for 3 or 4 hours. And so I am driven by measuring things and facts. I try not to use the word should. I try not to use the word I believe. I try and stick with what we can measure. So by using things like the booster, where I can put that on each side of a device, then I can definitively go in and say that this device is holding this for 35 microseconds. And if 35 microseconds is what breaking your application, then I think we have other issues that we need to talk about. The other thing that I found with the booster I really like is that we have the ability to go in and insert a VLAN tag based on which port the packet was received on. So I've got mine set up so that if it comes in on port 1, it gets 500. Port 2, 501. So now I can really start going in and creating filters that will grab traffic just from a specific port. So I've got, one that taps into the connection to my wireless network. I've got one on the inside of the firewall, one on the outside of the firewall. So when I want to go in and analyze a problem, or just like, we went through that long-term capture and how we could go back in time, we could, if we're capturing on both sides of the firewall, we can see what made it through and what didn't make it through. Because oftentimes we see people set up things like destination NAT rules that just aren't valid anymore, but they may be allowing traffic through that they don't even know about. So by monitoring on both sides of the firewall with something like the booster, I could go back in time and say, when was the last time this rule was really used? When was the last time we allowed traffic in on that? Maybe we should go turn that rule off because that rule really isn't being used anymore.
That definitely is a fantastic product, especially the size. When you showed the image of the actual booster itself and then the Iota. If you can actually put that image back up, I would love to have the audience just look real quick. So that Iota, that is the 10 gig Iota. Okay, it's got a terabyte drive in it, and look at the size of it. I remember back in the day, those Network General sniffers, those were things that were luggables that didn't even have this type of capabilities. It's amazing.
Well, I still have. I've got a couple of Dolces around, so I still have a couple of those. But while I've got this picture up, let me point out as well. We talk about the Iota being an inline tool, and we see that we've got our two SFP ports there, or cages on the front, that we can plug copper SFP, we can plug fiber, we can plug a DAC cable in. And those two ports can be set up to operate either inline or independently. So in this case, I've got it set up independently. So it's taking and capturing that traffic on port A. So the really neat thing is I can combine a single 10 gig Iota with two boosters to give me the ability to tap in line with up to 8 gig connections. So we talked about the packet broker before. Well, a packet broker, it's a very powerful piece of equipment. But what if I fall into that range where I don't quite need a packet broker yet, but I need to monitor more than one link? And this is where we see that as we combine the booster with the Iota, that I can tap into up to 8 links, send that traffic off to the Iota for monitoring. And then if I find I grow beyond that, then I may look at something like a packet broker. But even with the packet broker, and the reason that it's called the booster is it boosts the packet broker. Instead of using up multiple ports on the packet broker, we can go in and plug one booster in and connect that to a 10 gig port on the packet broker. So now you're using one port on your packet broker to monitor 4 links. And with tools, with packet brokers like the X23200, the lowest port speed on that is 10 gig. So the booster also provides a way to monitor 10, 100, 1000 links with that X23200 or the other packet brokers that only support 10 gig links.
It's very interesting. I need to now go get my propeller hat. We've been geeking it up big time. So yeah, we're coming to the close, Mike, and I wanted to, again, see if you had anything you'd like to share with us before we, close out today. I know that it's important to, utilize this type of technology, and if you can just, tell us a little bit about that in our closing.
It's the best packet analysis tool in the world is not going to help you if you don't have the right packets. So, and the best security tool is not going to protect you unless you can capture, you can see, you can block the correct packets. And so it is critical that we have the equipment, the best equipment out there on the market that's going to allow you to get in the path of those packets and see what's going on. And in the case of things like the ProfiShark and the Iota, to be able to capture and analyze that traffic. So just understanding how an analyzer works or how your security monitoring tools work isn't good enough. You have to be able to ensure that you're capturing that. And if you've heard one of my other presentations before, I'm really big on not using the S word. And the S word is should. We hear that used a lot in our industry. That should fix it. That should do it. That should get you the packets you need. We need to validate. We need to make sure that we've got exactly what we say we're giving somebody. And that starts by making sure that we have the best tools out there for getting that done. And again, that's what I've enjoyed with working with ProfiTAP is they take this really seriously and they go above and beyond. Every time we've talked about something, not only have they taken that and implemented it, but they've built on top of that and added something that we haven't even we didn't even think of before that.
And I know you and I talked about this before, but people don't realize when you're building out your network, don't wait until it's built out to get this type of technology, because it's important to be able to see what's going on as you're building it out and making adjustments for it at the same time.
Yeah, troubleshooting always seems to be an afterthought. Rarely do I ever see somebody build a network with maintenance and troubleshooting in mind. And like you mentioned, I see, most people wouldn't build a network without a UPS. And we should be thinking about how are we going to get in there and monitor the packets at the same time. When something goes wrong, how can we get in and see what's happening without having to break the network to do it?
Well, thanks for your time today, Mike. If anybody's interested in learning more about ProfiTAP, please feel free to reach out to us at Sinnott Wolach Technology Group. Mike, it was great speaking with you, and I appreciate your time today, and have a great rest of the day.
Thanks, Jeff.
All right, take care.
Thank you everyone for watching. We hope you enjoyed today's webinar. Check out our YouTube channel for previous Let's Talk Security broadcasts. Just go to youtube.com and search for Sinnott Wolach Technology Group. This episode is sponsored by ProfiTAP. Bring clarity to your networks. And produced by Events by Drew Productions. Let's Talk Security is brought to you by Sinnott Wolach Technology Group, a leading provider of next-generation network and information security solutions and services.